This lesson will be on potable water and pure water. So potable water is water that's been processed and is safe for human consumption and daily use. The difference between pure water and potable water is that pure water is solely made up of H2O molecules, water molecules, whereas potable water may contain different substances, usually dissolved minerals and salts. Now, in order for water to be considered potable, it must have the following three characteristics. So it should have a pH between 6.5 and 8.5. The dissolved substances such as salt will be within a normal range, so it can't be saturated with these salts or substances. And finally, it should be free of bacteria or potentially harmful microbes. Now, water is considered fresh when it's relatively free from dissolved substances. So an example of fresh water would be rainwater, which we get a lot of in this country. Water can be collected in reservoirs, lakes and rivers, and this is known as surface water. In addition, it can be collected in aquifers, which are rocks that collect water underground, and this type of water is called groundwater. So the origin of fresh water all depends on the climate in the region where the water is being used or collected. In warmer areas, such as in the southeast of England, water primarily dries up before it can be collected, so it's found underground as groundwater. Despite being relatively low in dissolved substances, there are still processes which need to take place in order for water to be safe and suitable for use. The two most important steps in this process are known as filtration and sterilization. During filtration, debris such as pieces of soil and dirt, small pebbles, twigs, etc. are removed by a wire mesh screen, such as what you see here. After this, other debris is filtered through sand beds and gravel, such as what you see here in these settlement tanks. Sterilization involves using UV or ultraviolet and ozone light to sterilize the water, or alternatively, chlorine gas is bubbled through the water, and this basically removes any dangerous bacteria or microbes. So if I was to number this process, number 1 would be water entering and passing through a screen of metal placed bars, and as mentioned earlier, that removes larger pieces of debris. Number 2 would be the settlement tanks, where sand and soil settle out. Number 3, aluminium sulfate and lime. This lime is calcium hydroxide, are added to the water, and small particles of dirt clump together so that they sink to the bottom of the water. That would be in another tank, in this one here. Number 4 is when water is passed through a filter of fine sand and gravel, so any smaller impurities, they won't be able to flow through the filter of fine sand and gravel. Number 5 is at a stage where water may look clean, but it still contains harmful bacteria which you can't see. So to combat that, chlorine, ozone or UV treatment would be used to kill bacteria. And the final stage is where the pH of the water is checked and corrected so that it's neutral. It is then stored in large tanks and service reservoirs, and obviously it can be transported to wherever it's required. So if aquifers are not present or the collection of surface water is limited, the process of desalination must be used to give potable water to the population. Desalination is essentially removing the salt and minerals from water in order for that water to become potable. So desalination, it involves the treatment of seawater to remove the salt by either distillation or reverse osmosis. In terms of distillation, this is a very simple illustration demonstrating what distillation would involve. It's where you have a mixture heated in a conical flask, such as what you see here, and obviously the pure water vapor is then going to the water is going to boil and it's going to evaporate. This here is known as a condenser. So when it flows through the condenser, the steam or the water vapor is then going to cool, and it's going to be collected in a separate beaker, and that would be pure water. The reason distillation works is because the pure water, it's going to evaporate before the whatever's dissolved in there. That's why the use of the thermometer is important. The advantage of distillation is that water can be made pure from any source, such as seawater or from water from marshes. A disadvantage is that it'd be very expensive, as a lot of heat energy is required. Reverse osmosis is a process which involves the use of membranes, such as what you can see here. Now, it's different to normal osmosis because in reverse osmosis, pressure is applied, and what that does, it only allows water to travel through the membrane, and any larger molecules or ions cannot pass through the membrane. In terms of advantages, it increases drinking water, it does not require energy, it's cost effective, and it can remove fluoride, chlorine and other impurities. The disadvantages, the main two, would be that it takes time and requires regular maintenance. Now, desalination as a whole is an expensive process as it consumes large amounts of energy, so it's not really ideal when producing large quantities of fresh water. It only ever be used in regions with very hot climates, such as in the Middle East.